Hi there everyone. This is a 5-week update on the zinc carbon cell recycled. This is the one containing the dead batteries contents, manganese dioxide and some extra carbon shop bought activated charcoal for the center. It's got a zinc plate from the battery that the manganese came out of, and seems on this cell the zinc plating is starting to corrode really badly. We've lost the tab, so I've just put this aluminium pot rivet just touching some of the plate. It's pretty dead, this cell. The double carbon fullerene cell carbon is quite surprised. It was sort of like that cell for a while with just Epsom salts until I decided to add some, where is it? Yes, some zinc sulphate. But you can't add too much of the zinc sulphate to the Epsom salt solution. It turns into sort of hard crystals. That's adding too much, but you can actually dissolve 1 gram into this size solution. I would put too much in there and it just drops out. But for 2 weeks I've been feeding this double carbon cell with the zinc sulphate and Epsom salt solution, and put that one to the side for now. This is the recycled battery cell. We'll just check it out, just to see what's got in it. Voltmeter's set on 20 range. We're set on the 200 milliamps for this meter. I'll be surprised if this actually does anything. It does sort of charge up, but it won't hold a charge very well at all. We're sitting at 0.9. It's pretty dry in that cell for a short circuit. See the meters, we're only like 2 milliamps, not very good. I've got some Epsom salts here, so we'll see what happens when we sort of re-wet it. It should really be a zinc air cell, zinc air cell really, but it doesn't function as good as one of them because I have 2 little zinc on the bottom and carbon on the top, with a little bit of a copper electrode pushing on the carbon in Epsom salts, and these 2 little cells perform better than that one. So we went back up to 1.2 volts, and the short circuit is sort of a little bit higher, but nothing too great. These have been sitting around for 5 weeks now, and last time these were charged was 5 days ago on a 10-minute charge each one. Not 10 minutes, it was 10 seconds at 12 volts, and that's the results of this one. Barely nothing in it. This one's quite surprised. That's the fullerene one, double carbon. It's still intact. The zinc doesn't look like it's been dissolved at all. And for this little one, if I can get that clip on. There we go. Alright, we have about the same voltage, but for a short circuit on it is 70 milliamps after 5 days after a 10-second charge, which isn't too bad actually. That's functioning like it sort of was. It's a bit higher, and it runs the motor, no problems. That'll probably run for ages, and on a charge, we'll give it a charge of set the charger voltage to about 5, just under the 5 mark. Oh, where is it? There it is. So we'll give it a minute's charge just for a test. That's got Epsom salts and zinc sulphate added to the electrolyte over 2 weeks. So it's had about probably 4 refills. You can only put a little bit in there. I topped it up a little bit earlier. And the funny thing on this one, we'll set that to the 10 amp range for the charge. Now connecting the charge now. Oh no, we're only doing 20 milliamps. Oh, okay, that's not the charge. Here's the charge. That was running the motor. There we go, 240 milliamps going into it. I'll set that and I'll be back in 1 minute's time. Okay, we're coming up to 1 minute's charge. And 1 minute, disconnecting the load. The charger. I'll set the amp meter back to milliamps. And for a short circuit on it, over here, we're 130 milliamps. It really cranks the motor up, and the voltage sort of goes down quite slowly. On a 2-hour charge, the thing performs way better. But just the addition of zinc sulphate made all the difference in holding its charge over days. It definitely drops in charge still because it still leaks, but it's this one doesn't hold its charge over a day. But the manganese dioxide in this cell was pretty depleted, I'd imagine. It was really old batteries that all came out of. But just double carbon, not too bad. And the cell shouldn't even be in a chamber with a carbon outside of there. It should be the separator on the zinc, then carbon all the way to the carbon electrode. So it's got a double layered sort of thing, which I sort of think hinders the performance. So I might test that and get this cell and put the separator on another piece of zinc and then fill the rest up with charcoal and an electrode and see what the difference is, plus the zinc sulphate. Yeah, so we're holding charge now. Voltage is sort of staying there for a while the load's still running. So that's pretty much for this video. Well, I'll disassemble this one, put the separator around it, and I'll get back in another update, probably a couple of weeks or whenever this one sort of dies or something. Alright, thanks for watching. Just a quick update. The cell, the double carbon cell, had a half-hour charge at 5 volts and it's been resting for 48 minutes now, and our voltage is 1.5 volts, and for a short circuit after half hour sitting around after a charge, we have 100 milliamps. And for a quick little run of the little motor, oh yeah, we're bouncing back up a bit. Alright, for a run of the motor, it's delivering 47 milliamps. Voltage is slow. Yeah, so I'll let that sit overnight and I'll check it tomorrow. We'll see what it bounces back up to. Okay, there we go. Double carbon cell zinc. Thanks for watching. Hi there. Back with the manganese on the zinc plate. Seems to consume it pretty quickly. So I guess you don't put the manganese on the zinc side because it's totally just crumbling. That's why that wasn't. And another thing, the stainless steel mesh is totally eaten. You can sort of see a piece of it there. That's this gauze matting. It's stainless. Doesn't stick to the magnet or anything. So yeah, probably if I had the separator on the zinc and then the manganese and then the electrode, it probably would have been a better battery. Oh, and look at the gloves. Yeah, nightmare. Wait, no mesh in there at all left. Totally consumed, doesn't even feel prickly. I can see shiny bits. I don't know if you can see them. But I think that's the remainders of the steel mesh or the stainless mesh. So much for keeping the little inner tubes. Okay, so we'll keep this one alive and see what happens. It's forming a glassy type substance. Alright, thanks for watching.